Morning, students. Today we are going to discuss about motion in a straight line. సో ఇప్పటి వరకు వర్క్ పవర్ ఎనర్జీ లెసన్ నుంచి ఇంపార్టెంట్ క్వశ్చన్స్ వర్క్ ఎనర్జీ థియరం ఫ్రీలీ ఫాలింగ్ బాడీ కొలిజన్స్ దానికి సంబంధించి వెర్టికల్ సర్క్యులర్ మోషన్ అండ్ ప్రాబ్లమ్స్ కూడా దానికి రిలేటెడ్గా ప్రాబ్లమ్స్ ఐపీకి మనకు సంబంధించినటువంటి ఇంపార్టెంట్ క్వశ్చన్స్ని మనం డిస్కస్ చేసుకుంటున్నాం. సో ఇదే విధంగా ఫస్ట్ ఎస్ఎస్ కంప్లీట్ చేసాం. ఇప్పుడు మోషన్ ఇన్ ఏ స్ట్రైట్ లైన్ అనే లెసన్ నుంచి ఆ లెసన్లో మనకి ఇంపార్టెంట్ క్వశ్చన్స్ ఏంటి, దాంట్లో ఉన్న ప్రాబ్లమ్స్ ఏంటి. సో మోస్ట్లీ ఇన్ ఏ స్ట్రైట్ లైన్లో నుంచి మనకి ఎక్కువగా ప్రాబ్లమ్స్ అడగడం జరుగుతుంది. సో ఈ ప్రాబ్లమ్స్ ఏంటి, అలానే దాంట్లో ఉన్న ఇంపార్టెంట్ క్వశ్చన్స్ ఏంటివి, ఇవి ఈరోజు క్లాస్లో డిస్కస్ చేసుకుంటాం. సో మన ఫస్ట్ క్వశ్చన్ వచ్చేసరికి ఈరోజు సో రాది S is equal to ut plus half at square. S is equal to ut plus half at square and Vt graph method. Vt graph. So in Vt graph method, so we can prove the S is equal to ut plus half at square. Suppose a particle is moving in a straight line with uniform acceleration. A particle, its initial velocity, so here initial velocity u, and moving with the initial velocity with an acceleration a, and final velocity going to be v in a time t. Final velocity in a time t, that is represented a b, that is represented AB. Then it can be, we can written as, we can take the common, then we can write this one is the C and this one is D. So here we can observe the initial velocity of OA is U, and the final velocity of acceleration particle moving from A to B. Then here we can observe from VT graph velocity and time graph. So here O, A, B, C, D and O. So this is the graph. From this one we can write so first one we can observe this one is the triangle and second one is look like a rectangle. So then we can write from area of triangle, area of the triangle, and second one area of the rectangle, area of the rectangle, area of the rectangle. So here area of the triangle, that is A, B and C, and area of the rectangle is O, A, C and D, O, A, C, D and O, O, A, C, D, O. So here the displacement is S, and what is the area of the triangle formula? Half into BC into AC plus what is the area of the rectangle? AO plus AO into OD. So here we can observe the initial velocity U and final velocity V, then it can be written as V minus U. From the kinematic equation we can write V is equal to V, S is equal to half into what is the BC? So here BC is V minus U, V minus U, and AC, what is the AC? This one is the time T, then T plus AO or OA, initial velocity U, and OD, the time taken T. Time is T. From the kinematic equation, V is equal to U plus AT. It can be written as V is equal to or V minus U is equal to A. We can replace the value V minus U is equal to AT. Then it can be written as S is equal to half into, in place of V minus U, we can replace the AT. A into T plus UT. Therefore, here T into T, here T into T, T square. Then S is equal to half into AT square plus UT. Therefore, S is equal to UT plus half AT square. So this is a solution from the graphical method of S is equal to UT plus half AT square. So listen once again. So consider a particle with initial velocity u with an acceleration, then the final acceleration a, the particle moving in the final velocity in a time t. The acceleration a b. So here we can draw the diagram. Then we can observe this one is the triangle. It won't be represent a rectangle. So then here initial velocity u, final velocity v in time t. So what is the difference between b to c, v minus u and time t? From the graph we can write the area of the triangle plus area of the rectangle. So what is the formula of area of the triangle? Half into bc into ac, means height into breadth. So that is bc into ac. Then plus area of the rectangle, that is oa into od. Then we can write S is equal to half into BC, means what is the value of BC? Final change in velocity V minus U, final velocity minus initial velocity, into AC distance is in time t, then it is t plus OA is equal to initial velocity and OD is the time t, then UT. Then S is equal to, so here we can observe from the kinematic equation, we can write the V minus U is equal to AT. We can replace the value in place of V minus U, then half into AT of T plus UT. That is equal to S is equal to half AT square plus UT. You can write the in order S is equal to UT plus half AT square. So take a screenshot. Yes, coming to the next second one. A particle moving in a straight line with uniform acceleration, its velocity time t is equal to 0 is v1 and time t is equal to t in v2. The acceleration velocity of the particle in time interval is average v1 plus v2. Is this correct? Is this correct or not? And substitute your answer. First one, so given data, is this correct? Yes, it is correct. Yes, it is right. Then how to prove this one? So here the acceleration is equal to written as delta v by change in velocity by change in time. Therefore, acceleration is equal to v2 minus v1 by t2 minus t1. That equal to, so here velocity changes to v1 to v2. Therefore, v2 minus v1 by, but time changes from t2 is t and t1 is 0. Therefore, t minus 0, that is equal to v2 minus v1 by time t. So this is the acceleration, and this value is substituted in the displacement displacement particle, that is S is equal to ut plus half at square. S is equal to ut plus half at square. Here u is equal to v1 and a is equal to acceleration value v2 minus v1 by t. So we can substitute these two values in the above equation. We will find out the answer. S is equal to ut means v1t plus half into A means V2 minus V1 by T into T square into T square. So here we can observe the replace the A value. A is equal to V2 minus V1 by T. So here T square T cancel and remaining term we can write the remaining term here that is equal to, so here V1T plus V2 minus V1 by 2 into T. 2 into T cancel, so T. So here we can observe in both cases we can take the common T. Then V1 plus V2 minus V1 by T, sorry, 2 into T. So here we can take the LCM 2, then it can be written as S is equal to 2V1 plus V2 minus V1 by 2 into T. So here 2V1 minus V1, that is V1 plus V2. Therefore S is equal to V1 plus V2 by 2 into T. So this is the displacement vector, but we can find out the, so what is the we can find out the acceleration of the velocity. So here we can find out the velocity of the particle. So velocity is equal to displacement by time. Velocity is equal to displacement by time. So here displacement value is v1 plus v2 by 2 into t by the time t. So therefore t cancel and remaining answer is v1 plus v2 by 2. So this is the answer v1 plus v2 by 2. So substitute your answer, then we can find out the answer. Yes, sir. A particle moving in a straight line with uniform acceleration, its velocity at time t is equal to 0 and v1, and time t is equal to t in v2. The average velocity of the particle in time interval is v1 plus v2 by 2. Yes, sir. This is the right average particle velocity is v1 plus v2 by 2. So first of all, so given statement is true. So we can find out the acceleration is equal to change in velocity by time, that is equal to v2 minus v1 by t2 minus t1. So here there is no change in velocity, but the time changes from t minus 0, then v2 minus v1 by t. So we can find out the displacement s is equal to ut plus half at square. But here u is equal to displacement v1 and A is equal to V2 minus V1. We can substitute these two values in our equation. That is S is equal to V1T plus half into V2 minus V1 by T into T square. Here square and T cancel, and we can write the S is equal to V1T plus V2 minus V1 by 2 into T. Then S is equal to V1 plus V2 minus V1 by 2 into T. So here we can take the common term T. Then we can take the LCM to 2v1 plus v2 minus v1 by 2 into t. So here 2v1 minus v1, that is v1. So then v1 plus v2 by 2 into t. But here we can find out the velocity. The velocity is equal to displacement by time. Then displacement s by t, that is equal to, what is the displacement for value? v1 plus v2 by 2 into t. Then by t. Here t going to be cancelled. Then we can write the final value v1 plus v2 by 2. So take a screenshot.